Let's do one by one. Ready? Oh, did you get that one? Yay! Okay. 21. No, it's not. But that was one of the factors you had to find. Negative 21 and positive 8 there. Yeah. Annalise, what's up? For number 1. It sounds like you might have factored not in a correct way. Talk to me about how you're factoring this. No. Oh, that might be the problem. Okay, so that causes some issues for students, and maybe this answer your question too, Sam. Yes, and that was the same thing I was just going to say. I work super duper super hard to keep what's called the leading coefficient, the thing that's holding the highest exponent in the problem. I work super duper hard to keep that positive. Because when it's negative, we talked about in the GCF method, you're going to want to pull that negative GCF out so that when you go to group it, there's not an error. And it sounds like with that negative value in there, you forced out an error for yourself. So I go back in when you have some time, maybe a little later on. See this x plus 3 right here? Subtract x and subtract 3 from both sides to get one side equal to 0. That'll keep that leading term positive for you. Yeah, in general, it'll make for a happier life, I swear. Alyssa? A negative GCF, yep. Oh, yeah, that's okay. Isn't it like a magic trick? Yeah, it is like a magic trick. Yeah, and Alyssa too, yeah. It's actually an old method for teaching AC, the AC method, that we used to teach a while ago, but we got rid of it because you're like, what? How does this even work? And we don't ever want to teach math in a way that doesn't come off logical, that seems like contrived or magic. A little bit. It's a little more than I can get into right now, because if I did it for some people, you'd be like, oh, and I don't want to confuse anybody in the room. So yeah, I could probably talk you through that at some point during a study hall or homeroom or something like that. Yeah, after class. Honestly, the fastest way to do it isn't any of that. I actually do it in my head with a little like trial and error, and I get my 2 binomials right there. And that's actually the fastest way to do it, especially when you're looking at a problem. It doesn't apply here, but when this a value is a prime number, it's so easy to just guess and check. It's actually the fastest. There's no scratch work involved. So if I have time someday, that's where we're going to go. I'll probably go with that maybe more in chapter 5 when we do some more factoring. All right, last warm-up problem. Plus or minus 16. Careful, there's 2 answers. Okay, we're going to come back to this little exploration as our warm-up activity for tomorrow. But today's topic, you're getting your 3rd method out of 4, your 3rd method for solving for x in a quadratic equation. This method is what we call completing the square. This is a 2-day lesson. Today we're going to get through as much of the notes as we can. In one class I finished them, in another class I didn't. So we'll finish any notes that we need to finish tomorrow, and then you have a practice day. So tomorrow is just a kind of a day to let it simmer, let it cook a little bit, because this is actually brand spanking new. Nobody has done this, I don't think, in my experience in this room before. You are learning a new method today to solve for x, and yes, the name of that method is completing the square. It's 3 out of 4. So what's the idea when I say the phrase complete the square? The first part of the lesson I wanted to focus on today is like, what does that phrase even mean? And when we say complete the square, we're kind of talking about situations where sometimes quadratics are not factorable. in which case there can still be an answer for x, and we can still find that answer for x. If we just take a moment to adjust the one side of the equation so that it actually becomes factorable, we could actually solve that for x. And we actually adjust that left side of the equation so that it becomes not just factorable, but one of our special cases. We turn that left side specifically into a perfect square trinomial. And did you hear the emphasis? I put emphasis on the word square because when I complete the square, what that means is I'm turning that left side into a perfect square trinomial. That's the square they're talking about, a PST. So for instance, let's run a couple of completing the square type things. This first example here, I have x squared plus 6x plus blank. I want to complete the square on this. In other words, I want to turn this into a perfect square trinomial or a PST. So I ask myself, what number could go in that blank so that I could use the square root method on this thing? Do you know, Kevin? It would be 9. True story, we have a formula for that number. So I'm going to tell you what that formula is. To find this number right here that he just helped me out with, we take our b value, divide it by 2, and square it. So I took 6, divided it by 2, that's 3. 3 squared gives me 9. So now I am going to go back through and do that square root method for factoring. So I'm going to stuff 2 sets of parentheses. The square root of x squared is x. The square root of 9 is 3. This sign in here is a plus sign, so both of those things must be a plus sign. So I turned this into a perfect square trinomial so that it was very easy to factor. The big kids don't write that answer like that. The big kids write x plus 3 times x plus 3 how? Yes, that is actually going to be very significant for today. Let's do it again one more time. Annalise.
So if there's a plus sign in the equation, like the plus 6x, then they're both pluses in the answer instead of minuses.
Yeah. Because, Annalise, it goes back to we're trying to create a logically equivalent expression. If I had minus signs in there, I'm not going to get a positive 6x back out when I FOIL. I get a negative 6x back out. So it kind of goes back to the fact that if I FOIL this guy right here, I have to get that original trinomial back out. Does anybody know the number that would go in that blank right there? Not it. It would be 4. Now, if you can't mentally think of what that number would be, we do have a formula. I use the formula all the time, to be honest. Negative 4, cut it in half, square it up. This is why you had those problems on your homework last night, where you had to like square the negative numbers, that review set we talked about, because sometimes in this step I'll see that mistake. We're going to square this entire value. So we're doing negative 2 quantity squared. That's negative 2 times negative 2. That's a positive 4. So do you see, I completed the square because I turned this left side into a perfect square trinomial. I made it a square. So now it's easy to factor with my square root method. Square root of x squared, that's x. Square root of 4, that's 2. Annalise is picking up on the fact that if this is a minus sign right here, both of those need to be minuses. The big kids don't write the answer like this. They write it like this because it's faster and significant for today's lesson. So that is what you do when you complete the square. Now, how does this help us solve a quadratic equation is probably what you're saying. Good question. I'm going to show you. In general, we have a formula for completing the square. That formula you need to pull out of today's lesson and memorize for now is b divided by 2 squared. Ultimately, there are 5 steps to completing the square. And now is your chance to write those steps down so that you can kind of think about them and process them a little bit. I'll read them nice and clear in case you're in the cheap seats. Step 1, we solve for the constant term. That's weird. You're used to solving for letters. We're going to solve for a number, get a number by itself. Step 1, solve for the constant term and get the constant term by itself. Step 2, only applies in certain cases. You don't always have to do step 2. Step 2, you'd have to divide through by whatever is multiplied on your squared term. So if there's an a value other than 1, a number in front of your x squared like 2 or 7, you have to divide that out of the entire problem. Again, the idea is to make it a perfect square trinomial. You can't square root 7x squared, so you gotta get rid of that 7. Step 3, we calculate the formula for today, b over 2 squared. You must add it to both sides. Step 4, this makes a PST on the left side. You can abbreviate this. Factor the resulting perfect square trinomial and simplify the other side of the equal sign. Step 5, we solve using the square root method, the method we did yesterday. Some of you affectionately call this piece SADMAP. We solve by undoing. I remember doing this method in high school. I was a pretty good math student. In all honesty, I had to do my math homework with my notes out, actually often, but I remember having my notes out doing this. I remember like going back and being like, what do I do next? What do I do next? Until I got the feel of how this was supposed to work.
Isn't there some first time just taught them?
No, when I was in high school, I had to go back and look at my notes to kind of figure out. Oh, my dear Doug. Everybody have their steps? All right, giddy up. Let's do it. Example 1, part A. Step 1. We must solve for the constant term. Get the constant by itself. You guys okay back there? Do you need a sec? I can. You sure? Okay. So what we're going to go ahead and do is add 6 to both sides. Do you see how this gets the constant term all by itself on the right side of the equal sign? This equation is now solved for 6. 6 is all by itself. What has opened up is an awkward gap in my problem. Do you see it there? This is usually my visual cue that I need to fill in that gap with something. And what I add onto one side of an equal sign, I must add on to another. Coincidentally, we have a formula for the number that goes in that box. B divided by 2, square it up. In this case, B is 2. So I take 2, divided by 2, square it up. 2 divided by 2 is 1. 1 squared is 1. If I add a 1 onto the left side of the equal sign, I must add a 1 onto the right side of the equal sign. That's my addition property of equality. Next, you'll notice I got to skip over step 2 in this case because there was no number in front of my x squared. I jumped down to step 3. And then what I'm going to go ahead and do right now is factor that left side. So I have x squared plus 2x plus 1. That does factor now. That's a perfect square trinomial. It factors with that square root method. So I square root the first part, square root the last part. Notice that that's a plus. So this is x plus 1 times x plus 1, or in this case we write it as x plus 1 squared. Also in step 4, you have to simplify the right side of that equal sign. 6 plus 1 is 7. Now it's a square root method problem, just like you did last night. So we just square root both sides. So I get plus or minus the square root of 7. Subtract 1 from both sides. And then I do want you to get in the habit of writing these out as 2 different answers. I actually wrote that down there before I forgot to erase from earlier today. Your 2 answers for this x value, you have -1 plus the square root of 7 and -1 minus the square root of 7. Not this method. This method finishes up with the square root method every time. Because you turned that left side into a perfect square trinomial, something squared, so you're always going to end up square rooting both sides at the end. That's why I had to teach you yesterday's method before today. You ready to try it? Let's see if you can do it. Those next 2 there are independent practice. Let's see if you can do it. I'll go ahead and let you know you have 3 of these tonight, and they're just like the independent practice problem. So why don't you go ahead and make sure you can do this a couple times on your own before you leave me today. I'm going to walk around and help you out a little bit. So far, this one looks really good. Again, you want to get in the habit of writing it as 2 separate answers. So I should add a step onto mine here. And then 2 minus the square root of 5. Reason being, these are just big decimals when it all cooks down. And you want to be able to check the place where this parabola would run into 0. So it is handy to check those as x-intercepts on your calculator. I'll show you how to do that in a couple days. But for now, this looks good. On part B, you're going to want to simplify a little bit at the end. A little heads up about that. This one also looks pretty good. I did see a couple of competing answers with respect to people leaving it unsimplified. So I did see a couple people who stopped at the square root of 60 or the square root of 45. Remember, you have to simplify this guy right there. So you get x equals 6 plus 3 root 5 and 6 minus 3 root 5 for your 2 answers there. I might get you situated on what we're going to talk about tomorrow a little bit since I have a minute. Does anybody need help with this last problem, though, before I kind of give you a sneak peek into tomorrow a little bit? Okay, let's get you started on tomorrow's types of problems. With respect to example 2, part A there, do you see visually the difference? What's wrong with this, Sam? Yeah, very good. And so if you think about how easy it was to factor with the square root method on the previous problems, you can't square root 2x squared because the square root of 2 is an irrational number. So we got to get rid of that too. Let's start this one. I'm going to go ahead and subtract 3 from both sides. Tomorrow's just a all right, that's that. This is where we'll pick off tomorrow.